So, Pluto's this tiny planet way out there, and it used to be called a regular planet. But then, some smart folks like Neil deGrasse Tyson and Miyoku started talking about it again. They think Pluto might crash into Neptune. How could that even happen? And what if it did? Is this a real worry? Or just some crazy idea? Let's think about what might happen if Pluto and Neptune actually collided. Pluto, which got demoted to a dwarf planet, is still interesting. Experts keep saying that Pluto's path around the Sun is pretty close to Neptune's. Guys like Neil deGrasse Tyson and Kaku are warning us that these two planets could hit each other, which might be really bad for Earth. But how could Pluto even crash into Neptune? Well, Pluto takes a crazy long time to go around the Sun, like 248 years. Since we found it in 1930, it hasn't even made one full trip yet. Plus, Pluto's path is super weird. It's not a circle like the other planets, and it's tilted at an angle. This makes its orbit kind of unpredictable. Here's something else that's weird. For about 20 years every orbit, Pluto gets closer to the Sun than Neptune does. So why haven't they crashed yet? The gravity from other planets keeps them apart. Scientists started studying Pluto's orbit as soon as they found it. It's not like the other planets, which stay pretty close to the same level. Pluto's orbit is tilted and shaped funny, and it crosses Neptune's path. But somehow, Pluto's orbit stays steady. It's a good example of how complicated things can get in space. It's like trying to figure out how three things, Pluto, Neptune, and the Sun, move and pull on each other with gravity. For Pluto, its orbit, Neptune's orbit, and the Sun's gravity all work together in a crazy way. Astrophysicists use terms like non-simultaneous vibration, orbital precession, and VZK wobbling to explain it. Non-simultaneous vibration means that when Pluto crosses Neptune's orbit, it's far away from Neptune. This keeps them from hitting each other. Orbital precession means that Pluto moves upward in its orbit. So, when it's closest to Neptune, it's high above Neptune's path. The VZK wobbling is named after three scientists. It's about how Pluto, Neptune, and the Sun pull on each other. This pulling affects how they move. The VZK wobbling helps us understand why Pluto's orbit is so weird near the Sun. Even though it seems wild, it keeps Pluto moving smoothly over long periods. These things help keep Pluto's orbit stable. Without them, Pluto could crash into Neptune or go off course. Back in the 1980s, some computer simulations showed that Pluto's orbit is actually kind of messy. Tiny changes can make a huge difference over time. Still, Pluto's orbit stays steady for billions of years. Studies show that big planets like Neptune, Jupiter, and Saturn affect Pluto's orbit. Neptune and Pluto have a special relationship. For every 2 trips Pluto makes around the Sun, Neptune makes 3. This helps keep Pluto stable. But Neptune isn't the only one helping. Jupiter's gravity also keeps Pluto on track. And Saturn helps too. Maybe Neptune, Jupiter, and Saturn are working together to keep Pluto safe. These things are super important. Without them, our solar system would be a lot more chaotic. Pluto could crash into other planets or get thrown out of its orbit. Understanding Pluto's orbit is important, especially if we're worried about it crashing into Neptune. It shows us how wild our solar system. Pluto's story shows how even crazy orbits can stay steady because of gravity and how planets move. It also reminds us to keep watching and learning so we can understand our place in the universe. Space is weird, and Pluto's orbit is a perfect example. Orbital chaos means that Pluto's orbit depends a lot on where it starts. Even tiny changes can mess up its orbit over a long time. Computer simulations are really helpful for studying how Pluto moves. Scientists can change small things in the simulations and see how it affects Pluto's path. These simulations showed that Pluto's orbit is kind of unstable, even with things like asynchronous vibration and orbital precession. If you change Pluto's starting position or speed just a little bit, its orbit can look totally different after a few years. But even with all this chaos, Pluto's orbit stays stable for billions of years. So, there's still some order to Pluto's journey around the Sun. It's super hard to predict where planets will go, especially when they have weird orbits like Pluto. These systems are so unpredictable that long-term predictions can be wrong. Computer models are helpful, but they have limits. They depend on having the right starting information. And even small mistakes can lead to big differences in the results. Besides all the chaos, Pluto reminds us that the universe is always changing. We've learned a lot about space, but Pluto shows us that there's still so much we don't know. Understanding how the big planets affect Pluto's orbit helps us learn about the whole solar system. It shows how each planet can affect the others. So, why are some top scientists worried about Pluto crashing into Neptune? Well, even though there are forces preventing it, Neil deGrasse Tyson has some thoughts. He's famous for changing Pluto from a regular planet to a dwarf planet. He's always learning and changing his mind about space. Tyson thinks the renaming wasn't a bad thing. It just means we're understanding our solar system better. He sees the weird orbits, like Pluto's, as a sign that there's still stuff to learn. That's what makes studying space so exciting. But even though Tyson is usually optimistic, he's a little worried about Pluto crashing into Neptune. He knows that even though Pluto's orbit has been steady so far, small changes could cause big problems. Pluto's path, especially where it crosses Neptune's path, is like a complicated dance that might not stay steady. Tyson thinks that even small changes to Pluto's orbit could have a big effect. If these changes add up over millions of years, they could lead to a crash with Neptune. But don't worry, these crashes wouldn't happen anytime soon. They would take place over a long, long time. Still, Tyson thinks we should keep watching Pluto and understanding its orbit. Tyson isn't the only one who thinks this way. Mio Kaku also wonders about the chaos that could happen when planets interact. Kaku shares Tyson's excitement about space, but he also knows that planetary orbits can be unstable and unpredictable. Both Kaku and Tyson say we need to keep studying the forces that control how planets move and what might happen to our solar system in the future. Pluto's story reminds us that we're always learning about the universe, and that new discoveries often lead to even more questions. As we learn more about space, the thought of Pluto and Neptune colliding reminds us that space is full of surprises. Even seemingly calm planets can change a lot in the future. Thinking about Pluto reminds us to keep looking at the stars and being open to new ideas. But Pluto's orbit is actually pretty stable, and that shows how complex space stuff can be. The three-body problem is about how three things in space like Pluto, Neptune, and the Sun move and pull on each other with their gravity. It's hard to guess where they'll go based on where they start. With Pluto, it shows how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complicated way. Astrophysicists talk about things like non-simultaneous libration, orbital precession, and VZK oscillation to explain this. Non-simultaneous libration means that when Pluto crosses Neptune's orbit, the two planets are always at least 90 degrees apart. This helps keep them from crashing. Orbital precession is when a planet's orbit moves a bit over time. With Pluto, it means that when it's closest to Neptune, it's far above Neptune's path. This gives it even more protection from crashes. VZK oscillation has to do with how three space objects pull on each other with gravity. This affects how they move and helps us understand why Pluto's orbit is so weird. Even though Pluto's orbit seems chaotic, this oscillation helps keep it moving smoothly over time. All these things help keep Pluto's orbit stable so it doesn't crash into Neptune or go off course. This three-body problem is key to understanding how orbits change because of how space objects pull on each other. Learning about this helps us understand Pluto, our solar system, and even stars in distant galaxies. Around the late 1980s, computer simulations showed that Pluto's orbit is actually pretty wild. Small changes can make a big difference over hundreds of years. But scientists have also found that Pluto's orbit stays stable for a very long time. Studies have also shown that big planets like Neptune, Jupiter, and Saturn affect Pluto's path around the Sun. Neptune and Pluto have a special connection where Neptune goes around the Sun 3 times for every 2 times Pluto does. This helps keep Pluto's orbit stable. But Neptune isn't the only one helping out. Jupiter's gravity also keeps Pluto on a steady path, possibly for good. So, maybe Neptune, Jupiter, and Saturn are all working together to make sure Pluto keeps moving safely through space without any accidents. These special things are key to keeping everything in place. Without them, the solar system would be a much more dangerous place. Things like Pluto could crash into each other or get thrown out of their orbits, which could cause problems for other planets. It's really important to understand Pluto's orbit especially since people are worried about it crashing into Neptune. This gives us a better idea of how the solar system works. Pluto's story shows how even wild orbits can stay balanced because of gravity and how planets move. It also shows that we need to keep watching and studying these things to understand our place in the universe. When we look out into space, we often see strange things. Pluto's orbit is a great example. Orbital chaos means that a planet's orbit depends a lot on where it starts. Even small changes in Pluto's location or speed can change its orbit in the long run. Scientists use computer simulations to figure out how Pluto moves in space. These simulations use math to show how Pluto and other things like Neptune pull on each other. By changing small things in the simulations, scientists can see how even tiny changes can make a big difference in where Pluto ends up. Back in the late 1980s, these simulations showed that even though Pluto's orbit has things like asynchronous vibration and orbital precession to keep it stable, it can still be wild and inconsistent. If you start with a slightly different location or speed, Pluto's orbit could look totally different after just a few years. But even with all this chaos, Pluto's orbit stays stable for billions of years. This means that there's some order to Pluto's path around the Sun. Even with all of these observations, predicting where things will go in space, especially with crazy orbits like Pluto's, is super hard. The way these systems are, it's hard to make good long-term predictions. Math models help us understand and guess what will happen, but they also show that we can't always know for sure. These models depend a lot on the right starting information, and small mistakes can lead to big errors in our predictions. Besides just orbital chaos, Pluto is a reminder that the universe is always changing. We've learned a lot about space, but Pluto's case shows that there's still so much we don't know. Figuring out how the gravity of big planets affects Pluto's orbit teaches us a lot about how the solar system works. It shows how each planet's location and size can change the stability and path of other things in the system. So, why are Tyson and Kaku so concerned about a possible crash between Pluto and Neptune? Even though all these forces keep it from happening, Tyson has a unique way of looking at our solar system, especially Pluto. He's famous for changing Pluto from a planet to a dwarf planet, and he has interesting ideas about how space stuff works and why people are so interested in the forgotten parts of space. Tyson thinks redefining Pluto was right because we're always learning more about our solar system. He doesn't think it makes Pluto any less important. He just thinks it's part of how we understand the things going around our sun. Tyson always learns and changes his mind about space stuff. Pluto's orbit shows how much there is still learn. Keeps the study of space interesting. Despite Tyson's enthusiasm, he's pretty worried about Pluto crashing into Neptune. He knows these orbits can be unpredictable. He knows that even though Pluto's orbit has been stable so far, small changes could lead to a disaster. Pluto's path, especially where it crosses Neptune's orbit, is like a complicated dance that might not always stay steady. Tyson thinks that even small changes in Pluto's orbit could have big effects. Over millions of years, these changes could add up and lead to a crash with Neptune. But it wouldn't happen anytime soon. It would take way longer than anyone's lifetime. Still, Tyson thinks we need to keep watching and learning about Pluto's orbit. Kaku also wonders about the chaos that could happen from planets hitting each other in the solar system. He agrees with Tyson that we need to keep studying the forces that control how planets move and what our solar system will look like in the future. Pluto reminds us that we're always learning new things about the universe, and new finds often lead to more questions. As we learn more about space, the chance of things like Pluto and Neptune crashing reminds us that the universe is full of surprises and that the seemingly calm orbits of planets can change a lot in the future. Thinking about Pluto helps us remember to keep looking at the stars and be open to the mysteries that are still out there.